Okay, today we're doing 4.3 matrix multiplication. So let's get started here. We know from the previous lesson in 4.2 with matrix addition and subtraction, we talked a little bit about the dimensions and which ones we can and cannot add, right? So let's take a look here with just starting pretty basic with scalar multiplication. So suppose C is a scalar, a real number, and A is a matrix. You find the scalar product by multiplying each element of A, which is your matrix, by C, your scalar, your real number. Okay, so let's try this one right here. There's a 3 in front, and we're going to multiply it to every element in this matrix. So we're going to go 3 times 3, that's going to give us a 9. 3 times 5 is a 15. 3 times 2 is a 6, and 3 times 8 is a 24. Okay, we can combine using scalars and the difference here. So we're going to combine those. So we're going to go 5 times A, so I'm going to multiply 5 times every element in matrix A. So 5 times 2, that's a 10. 5 times 1 is a 5. 5 times 3, 15. 5 times 4 is a 20. 5 times negative 7 is negative 35. And 5 times 5 is 25. Now we're going to subtract that with 3 times matrix B. So multiplying 3 to every element in matrix B here, we're going to go 3 times 3 is 9. 3 times negative 1 is a negative 3. 3 times 0, 0. 3 times 8 is 24. 3 times 6 is 18. And finally, 3 times 2 is 6. So now we're going to, we know that these are both 2 by 3. It's a dimension of 2 by 3. There are 2 rows here, and there are 3 columns here for both of these matrices. So we're going to subtract the corresponding elements. 10 minus 9 is a 1. 15 minus 0 is a 15. Negative 35 minus an 18. Negative 35 minus 18 is negative 53. 5 minus a negative 3 is 5 plus 3, which is an 8. 20 minus a 24 is a negative 4. And 25 minus 6 is 19. And here's our answer. Okay, so a little bit more here, one more like this, where we're solving matrix equations with scalars. So the first thing is to multiply in your scalar. So I'm going to just bring this down, 4x plus, I'm going to multiply this scalar to every element in this matrix here. 2 times 3, 6. 2 times 4, 8. 2 times negative 2 is negative 4. 2 times 1 is a 2. And then we're going to simply bring over that matrix by subtracting the entire matrix over, right? Since it says add this matrix, to get it to the other side, we're going to subtract that matrix. So subtracting this to the other side here, minus 6, 8, negative 4, and 2. Sorry, it's so messy. So we're going to come out with, these will cancel. We will get 10 minus 6 is a 4. 0 minus an 8 is a negative 8. 4 minus a negative 4 is the same as 4 plus 4, which is an 8. And then 2 minus 2 will give us a 0. Okay, and then multiplying both sides here by our reciprocal, which is 1/4. We will cancel that out, and therefore x will be equal to, I'm going to multiply this 1/4 to everything. So 1/4 of 4 will be a 1. 1/4 of negative 8, or negative 8 over 4 is a negative 2. 8 over 4 is a 2, and 0 divided by anything is 0. You can also take this matrix X and you can plug it in to make sure that you got the correct answer in the problem that we just had in the original equation. Here it is. Okay, moving on here. Here are some properties. We got scalar multiplication. We got A, B, and 0 are m by n matrices. These are dimensions. n by n matrices, and C and D are scalars. Just like when we multiplied in that number, those numbers C and D are scalars. So if we are multiplying C, a scalar, times matrix A, then it's still going to have the same dimensions, not changing the dimensions of a matrix. C times D times A will be equal to C times D times A using the associative property. Notice that these are both scalars though. C and D are both scalars. That's when we have the associative property. Okay? We're not using the associative property with two matrices, and we are not using the commutative property with two matrices of multiplication, multiplying two matrices. Okay? We got a scalar here for the distributive property. We got 1 times A will still be A, 0 times A will be 0, and so on. So let's take a look. Oh, we still got a little more. Okay, matrix multiplication has some of the properties of real numbers of multiplication. And let's take a look here. So for this here, we're looking at the associative property, but not the commutative property, which is what we just talked about before. Okay, moving on. Here we go, product of the dimensions of a product matrix. So if we have matrix A and matrix B, we're looking at the dimensions. So the dimensions here, we know we look at the number of rows. We got 1, 2, 3 rows. That's the number we put first, 3 rows. And then we got 1, 2 columns. So this is a 3 by 2 matrix for matrix A. Matrix B, we have 1, 2 rows, and we have 4 columns. 1, 2, 3, and 4 columns. So in order to multiply these matrices, these numbers here have to be the same. They have to be the same. Okay? And the outside numbers, the 3 and the 4, those are going to be the dimensions of the product matrix. So when you multiply matrix A and matrix B, it'll come out to be a 3 by 4 matrix. 3 by 4 matrix. Okay, so you first have to look to see if you can multiply the matrices, and then once you look, you know that you can, because these inner numbers are the same, then you'll look to see what the new dimensions are, and then we'll go about multiplying them. Okay, so now let's multiply. To perform matrix multiplication, multiply the elements of each row. Remember, rows are going horizontally. So of each row of the first matrix by the elements of each column. Here are the columns of the second matrix. Add the products. So let's see what we mean here. All right. Here's what we got. I'm going to make a big matrix here. We know that this matrix has dimensions of 2 by 2, and this one has matrix of 2 by 2 also. So since we're multiplying a 2 by 2 by a 2 by 2, and we know that these are the same numbers, then these outside numbers are going to be our new dimensions, 2 by 2. Okay, so now what we're going to do here is we're going to multiply it. So notice what it just said here. It said each row of the first and the column of the second. So you're going to take the row and the column. So we're going to take this row, we're going to take this column. That's how we find the first element of our product. So I'm going to go -1 times -3 plus 0 times 5. That's going to be my first element after I solve that. Okay? The next one here, we're going to go is, we're going to take this first row and the second column. So I'm going to go -1 times 3 plus 0 times 0. Okay, that's the next one. Then we move on to the second row. First column, 3 times, -3. 3 times -3 plus -4 times 5. And then finally here, we're going to use the second row. Sorry, these colors are kind of overlapping here. Hopefully not getting too confusing. Okay, second row, second column. So we're going to go 3 times 3 plus -4 times 0. Okay, so now we're going to just solve them and see what we come up with. That will be our product matrix. So now we will have -1 times -3. That's a 3 plus 0. This is going to be a -3 plus 0. This one is a -9 plus a -20. And this one is a 9 plus 0. So finally we get 3 plus 0 is a 3. -3 plus 0 is a -3. -9 plus -20 is a -29. And 9 plus 0 is 9. And here is our product matrix. We're going to see later on that if I switch the order of these, we're going to get something different from this here. And you guys can try that on your own if you want. Okay, let's see. Moving on, finding the product. So we know that the first thing we do is we look at the dimensions. The dimensions here, this is a 1 by 2, and this is a 2 by 1. So we look to see, can I multiply these out? Yes, I can multiply them out because the inner numbers are the same, and therefore my new dimensions are going to be a 1 by 1. You're going to get one number. That's it. So here we go. This is a 1 by 1, not the absolute value of x. 1 by 1. Okay. So multiplying this out, I'm going to get 12. So here's my brackets for my matrix. 12 times 10 plus 3 times -5. So I got 120 plus -15. And that is going to give me 105. That's it. It's my matrix, 1 by 1. See? 1 row, 1 column. That's it. It's 1 by 1. This one here, let's look at the dimensions. We look at the dimensions first, always, right? This is a 2 by 1, right? 2 rows, 1 column. And this here is going to be a 2 by 2. 2 by 2. So we look at the inside numbers here and cannot multiply this out because these are not the same. Okay? So there is no product of this. If it was switched and this 2 by 2 is on the other side, then you wouldn't be able to multiply them. But in this case, you cannot multiply them. All right. A used record store sells tapes, records, and CDs. Most of you probably don't use any of those anymore. Anyways, the matrices show today's information. I don't know if it's really today's, but it shows information. Find the store's gross income for the day. All right, so let's see what we got here. We got the price of tapes, records, and CDs, and the number of items sold. Tapes, 9, records, 30, CDs, 20. Okay. So let's look at the dimensions. This is a 1 by 3, and this is a 3 by 1. The inside numbers are the same, and therefore we're going to get a 1 by 1. Look, I made a little X, so it looks like a 1 by 1. Okay, so multiplying these out here, I'm going to go 8 times 9, right? We go first row, first column. 8 times 9 plus 6 times 30 plus 13 times 20. Okay, we're going to multiply that out. Here we go. So multiplying this out here, I'm going to go 8 times 9 that's a 72. 6 times 30, that's 180. And 13 times 20 is 260. Adding these all together, and I'm going to come out with 512. 512. So look back to see what they want. Find the store's gross income for the day. Here it is. This is going to be the amount of money they got for one day. Okay, determine whether the product R times S and S times R are defined or undefined. If it is defined, then find the product. Okay, let's see. Oops. R times S. Let's start there. So, R times S. R times S. R, here it is a 3 by 2. The dimensions, right? 3 rows, 2 columns. S is a 2 by 2. S is a 2 by 2. Since these are the same, then we can multiply them out. So our S is defined, so now we're going to multiply them out. Okay, let's do that. RS, here we go. We know that the new dimensions are going to be a 3 by 2, right? The new dimensions, 3 by 2, here it is. So we're going to have 3 rows and 2 columns. Okay, so, oops. I didn't want to do that. Okay, there we go. So, let's see. I wanted to erase this, though, so that I had a little bit more room. There we go. Okay. So, we are going to make this nice and big so that we can make 3 rows and 2 columns here and multiply it out. Okay, so I'm going to take first row, first column here. So multiplying that out, I'm going to go 2 times 8 is 16. 3 times 2, so plus 6. Okay? And then moving on. So first row, second column. I got 2 times 0 is 0, plus 3 times negative 5 is a negative 15. We're following? There we go. Moving on. Second row now. Maybe I should use different color. Okay, use different color now. Second row, first column. There it is. Negative 1 times 8 is a negative 8. 8 times 2 is 16. Second row, this you can look at the position it's in too to know what you're multiplying. Look, this is in the second row, 1, 2, second row, and the second column, right? So I'm going to multiply the second row and the second column, right? So I got negative 1 times 0 is 0. 8 times negative 5 is a negative 40. Okay, moving on there. So now we should change color again. Here we go. Third row, and first column. Okay, so third row, first column, that's the position this is in. 1, 2, third row, and the first column. So we got 4 times 8 is a 32 plus 0, right? And then we got third row and the second column. 4 times 0 is 0, and 0 times negative 5 is 0. Okay, so now we can finish this up here. We got 16 plus 6, that's going to give us a 22. 0 plus negative 15 is a negative 15. 16 minus 8 is an 8. 0 plus negative 40 is a negative 40. 32 plus 0 is 32, and 0 plus 0 is 0. Here's our product of RS. RS is equal to the product we just found. We knew it was going to be a 3 by 2, the dimension of 3 by 2, because of this here. Okay, so next we can look at S times R. S times R. Okay, S times R. So S, we just saw, that's a 2 by 2, right? And R is a 3 by 2. But we know that these have to be the same and they are not, which means SR is undefined. Alright, undefined. There it is, undefined. So we cannot multiply S times R, but we can multiply R times S. Let's see what else we got. That's it. Alright, so homework. Right here, you guys also have it on your green paper. We have a flipped class tomorrow, so make sure that you wrote good notes, and I'm going to post this on our Google Classroom. Hope you enjoyed. Thanks for listening. Bye.